Okay, hello. My name is Satish. Okay, I'm here giving you a solution of basic electrical engineering. Date of exam 26/11/2025, 2019 pattern. Here I'm discussing the first questions, two first questions of this paper. Okay, so let us first question. Here I started that define admittance status unit, express admittance in a rectangular and polar form. This is the first question. Four marks. Admittance. Y is measure of the how easily circuit of component follow the flow of alternating current. Serving as the inverse of impedance. Okay. So units of this quantity is SI unit, Siemens, and older, but you can still sometimes use that more. Okay. So more usually use that. Okay. So as a rectangular form is like this. Y is equal to G plus JB. Okay, here is this important. What is a G? G is conductance. Okay, which is a inverse inverse of resistance. B is a susceptance. That is inverse of reactance. And J is imaginary part. Value is a root of -1. Okay, so now you go for rectangular form. It is a it is a just a polar form now. Y is a magnitude. Okay, g to g is g to not g to it's a g square plus b square. It's a square root. Okay, and after taking this you get a y magnitude. Okay, and the y is a inverse tan inverse of imaginary part upon upon real part. Correct. So it is normally b upon g. This is a polar form. Okay, polar form. Okay, and next as a mark distribution here. Okay, this question is for 4 marks. Okay, and for 4 marks here, 2 marks for definition, 2 marks for polar form. Okay, we are presenting. Hmm. So this is a simple task for students. Next question number B, or question number 1. B is for 6 marks. Okay, obtain an expression for current when voltage V Vm sin omega t is applied across purely inductive circuit. Also draw the waveform for voltage and current against time as common x-axis. Okay, so this is a circuit diagram. This circuit diagram is very important. Okay, here circuit diagram is given. Supply alternating voltage supply. Its nature is sinusoidal, medium sin omega t, and pure inductive device is connected across this supply. Okay, so the equation is formed here. Governing equation: the voltage across the pure inductor and with N is released related to the current. Okay, going to feedback equation is equal to L into di by dt. Okay, so it is very by understanding that real is nature that opposite changing current. Normally we use this equation for the right source. Okay, Vm upon Vm into sin omega. So applying this equation, this drop voltage is equal to the source voltage. Correct. Now we are going to integration for eliminating this differentiation term. We are taking integration, and by taking the integration we can calculate a current value. Okay, so current, how are you going to calculate? So we have this. So here di by dt Vm sin omega t is I is equal to, so I is equal to here integration of Vm upon L. Here this term we are going to divide on right hand side sin omega t. Okay, Vm upon L is a constant. You take from the integration. Varying term is omega t, time is value here. So obviously you are going to take integration of sin omega t dt. So integration of sin omega t is minus cos omega t. As a function omega t, you are going to divide the depreciation of omega is equal to omega. Okay. So I is equal to minus Vm upon omega L. Omega is constant. So omega is normally influence reactors can consider here. So cos omega t. This is a actual form. Okay, actual form of equation which is we get current. Okay. Now the expression can write like this. We can replace this minus cos by sine of theta minus pi by 2. Okay, so I is equal to Vm upon omega L r Vm upon omega L sine of omega t minus pi by 2. Okay, this is the expression for a current. Okay, now next thing is this step 3 expression for maximum current. Okay, the term omega L inductive reactance limited by omega XL, which is opposition to the flow of AC current measured in ohms. Okay, so maximum current Im is defined as Im is equal to Vm upon omega. Only one parameter offered by the inductor is XL. Okay, opposition offered by the inductor is considered as a reactance. Vm upon XL. So substituting this Im value here like this. Im is a maximum value. Okay, now this Vm upon XL is replaced by Im value. Okay, so this is a expression which mathematical representation things we are going to discuss. Now here we have to discuss this is very important point. Here they already mentioned we take a draw waveform and take a time as a on the x-axis. Okay, so omega t is considered as angular distance, angular radian distance we can consider here. So this like here this is main reference voltage waveform starting from 0. Okay, and after interval, okay, after interval current get introduced in the circuit. Okay, so because of as a nature of inductor, it is opposed to change in current. Okay, so this is a question for 6 marks. Correct? 6 marks if we consider this. Okay, so marks 3 marks is divided for derivation. Here 3 marks for derivation and waveform and current expression 3 marks. Okay, easiest. Next question is there. Question 1 C. Question number 1 C. This question. So RLC has a resistance of 50 ohm, inductance of 0.1 and capacitance of 50 microfarads connected across the base 230 volt 50 hours AC supply. Okay, so here's RLC series circuit. The given value of parameters. Okay, so they want to calculate inductive reactance, capacitive reactance, impedance, current drawn by circuit, power factor of the circuit, active, reactive, power by the circuit. So first thing how you do, go step by step. This question is for 8 marks. Okay, it is 70 marks pattern. So the C question, C question is allocated for 8 marks. Okay, step first, calculate inductive reactance. It's a usually simple formula. X equal to 2 pi f. Well, okay, the calculation gives us that 31. Just putting the value with the units, if you putting a unit, it will be simple. If you get a proper understanding, okay, it will be a proper understanding. So 31.42 ohm is the value answer of Excel. Next, calculate capacity reactance. One by one, you just calculate. So this for capacity reactance formula is X is equal to 1/2 pi Fc. Basic formula. So the value get 63.66. Just putting the parameters, okay, putting the parameters like this. Here, uh, 2 pi f is 50 hours, and this remaining term is 15 to 10 raised to minus 6. Okay, minus 6 farad, microfarad. Next, we calculate impedance. Impedance, so Z is equal to R square under root R square minus in bracket XL minus XC in bracket complete square. You get the value 59.50 ohms. Okay, this is the actual total opposition. Okay, impedance of body impedance. Okay, next the current on calculate total current. Okay, so the applied voltage is 230 volt. Just take as this, divided it, you get the value nearly 3.87 ampere. Correct. So calculate the power factor. How are you going to calculate power factor? Cos phi is equal to R upon Z basically. Okay, as if you draw impedance triangle, you get a cos phi. Okay, cos phi is the angle between Z and R. You get the value like this, R upon Z. Correct. So here is the X is greater than XL. So cos phi is a leading. Cos times power factor is linear 50 ohm on 59.50 ohm. You get the value leading of 0.84. Now you are going to calculate active and reactive power, step number 6. So how you are going to calculate by using this formula. Formula is very important. Okay, P is equal to VI into cos phi. So V value is 230 volt, current value is 3.87 ampere into 0.84 is really equal to 747.22 watt. Okay, here's the value. The active power unit is watt. Then reactive power Q. Power is stored and returned to the stores. Okay, not going to consume. It is just within the element. Okay, as considered here. Okay, Q. Q is VI into sin phi. The sin phi value is XL minus XC upon Z. You can calculate directly by using calculation. You get the value of like this of sin phi is minus 0.54. So Q is equal to 230 volt into 3.87 ampere into minus 0.54 may be equal to minus 481.90 watt. Okay, this is where the reactive power unit is a watt. Okay, so this question of 8 marks. Now these are overall summary. Okay, so next question, question number 2. This is a one question or question. Okay, it's question number 2. Now question number 2 is first question, a small sub question. Draw power triangle for RL series circuit. Define active power and state it's a unit. Okay, so this is a triangle. Normal this is triangle. Okay, the student, this is a right angle triangle basically. Okay. So the horizontal parameter component is a VI at power VI input is equal to VI into cos theta that, okay, at the some sides. Then here's vertical component is considered reactive power which is equal to VI into sin theta VI units, and its hypotenuse resultant uh, component resultant of we can consider here the summation of this. Okay, so yes, it's equal to VI into cos VI, just VI, not any kind of parameter. This is apparent power, complex power. Okay, normally. So this is a question for 4 marks. We are going to draw triangle clear 2 marks, and active power and its units are definition and units is 2 marks. Total marks are 4 marks. Okay. So definition is here active power means active power is also known as real power, and true power is electrical power that converted into the other form such as heat, light or mechanical work in a AC circuit. Okay, actually going to consume this power, okay, into another form. So the unit is watt, kilowatt. Formula E is equal to VI cos theta, or we can take as a consume the power as a P is equal to I square into R. This is also one kind of active power. Now question number 2b. These are the expression for resonance frequency. In the case of series RLC AC circuit, draw the figure diagram. This question is for 6 marks. Okay, so let us see this. What is this questions? Okay, just the formula. This is RLC parameter. So there is one experiment for the RLC resonance component. Okay, so reactance formula is X is equal to 2 pi r, X is equal to 1 upon 2 pi FC. This is reactance, capacitive reactance, inductive reactance. Okay, both are equal. Okay, so if you know the games of zigzag is for game with okay, as the balance going to make. So this is a we require one kind of balance to occur a resonance. So 2 pi f L is equal to 1 upon 2 pi f C. Hmm? Just solve it, you get a frequency like this. Okay, for 4 pi square f square you can see is equal to 1. Here, FC f R is resonance frequency is equal to 1 upon 4 pi square LC. We're taking the square root. F R is equal to 1 upon 2 pi under root LC. So actually see this how this is vector diagram is very important. So there is a voltage vector in inductor. Here upper side in 90 degree and voltage across the capacitor in lower side in okay within 90 degree. So and main thing is main voltage which is VR, okay, is actually reference voltage. It can take in a phase current also vector you can show here in currents. Okay, so they are different, they are cancelled to each other. Okay, they are out of phase to each other. So they are shown in 180 degree. Okay, so these are the diagrams. Next question number 2. Question number 2C, the 8 mark question. Okay, now this question is okay, series RC circuit consisting of resistance of 50 ohm, capacity of 100 microfarad RC circuit. Okay, with supply to one single phase 230 volt 50 volts AC supply. Calculate capacitive reactance impedance of the circuit, current through circuit, voltage across the resistance, voltage across the capacitance, the power factor of the circuit, power consumed by the circuit, and so on. The phasor diagram. Okay, so these are the things are I think 7 things are there, but it is considered as one each marks. Okay, 1 mark for unit. Okay, normally. So this is a XC. X is formula 1 upon 2 pi C. So here same example, not the same again, but we get the value of 31.83 is a reactance, okay, capacity reactance. Oh, then total impedance we consider as resultant square root of R square plus C square. So we get the value 59.297. Okay. So the total current we get that V upon Z is a 3.88 ampere. Now VR, okay, VR is actually voltage drop across the resistance, okay, into R. So sorry, I into R, 3.88 into 50, 1.94, sorry, 194.02 volt. Okay, this can multiply. Then next, calculating that voltage across capacitor. Okay, this is I into XC is equal to 3.88 into 31.88 is equal to 123.153.52 volt. Okay, and it's normally it is a RC circuit, so power factor is leading. So 0.844 is leading here. Okay, so next we are going to calculate the power consumed by the circuit. We are into cos phi. So value of power consumed, active power is 30 into 3.88 into 0.844 is equal to 752.87 watt. These terms, okay, if you write within unit, you get 8 marks. Each carry 1 marks. Okay, so hence here I just covered the first 2 questions. Okay, remaining questions I will cover in next video. Okay, here I'm just starting a thing. Okay, for purpose to support the student. Okay, so here is class one, class BrightWaySolution class. Okay, here I will show the contact number. Okay, you can join this class. So here I for help you support your students, any kind of students, any kind of subjects. Here any kind of means engineering, particular engineering subjects is like an M1, M2 also, M3 also you can take classes with affordable speeds, with your time online or any offline. Okay, so as usual you can contact me on this number. I will definitely support you, and next video I will share, okay, very soon. Thank you.